All right, so here's part 2 of our investigation of correlation and regression. This is going to be a simultaneous Excel demo and working out a couple different types of calculations that we might do relative to correlation and regression. So here we have an example shown in this Excel spreadsheet, and we measured both body weight in these crabs. These are shore crabs, little green striped crabs that you find along the beach where there's rocky areas, and their body weight was measured, as well as their gill weight. The gills had to be dissected out and measured. And the question here had to do with, do the gills increase in size with the body proportionally? Or do, for example, larger crabs, do they need as big of gills as smaller crabs do? Another reason we might be interested in this relationship is if we wanted to see how crab body weight to gill weight relationship might be different under crabs that were raised at different temperatures, for example, if we wanted to see the effects potentially of global climate change in the future, for example. All right, so for each individual crab, crabs number 1 through 12, we have a measurement of the body weight in grams and of the gill weight in milligrams. So we have these two variables, X and Y, for each individual. So this is a fairly small sample size for correlation and regression. It is still going to be a long and tedious calculation. So we don't typically do these calculations by hand, but I want to show you how, because that is important for you understanding what we're doing. All right, so I'm going to transition to doing paper and pencil. And I haven't rewritten down every single individual observation on my paper, and I'm going to go through setting up how to find the calculations. And so you can do every step, pencil and paper, yourself, but you should be able to see how it's done based on the work that I showed. It's just really like you are smart people. You don't need me to do every single step. Okay. So those values. Notice I started with crabs 1, 2, 3, 4, ... until I got to the last one, little n. All right. So remember, when we're calculating mean and standard deviation, each of these individuals is being represented in our formula by a little I. So that this is for crab X sub 1, this is Y sub 1, this is X sub 2, this is Y sub 2. All right, so we're going to go down all the way to little I equals n, and our n for this example is 12. In order to make correlation regression calculations, I first need to calculate my X bar, mean for my X variable, and the standard deviation for my X variable. So these are 12.0 and 6.5. Notice my decimal places match my data. I also need to find my Y bar, my mean of my Y variable. This is 196 milligrams, and the standard deviation of my Y variable, 106. All right, so I have a couple different tasks. The first task I'm going to do is find my little r. All right, so part 1. Find little r, the correlation coefficient. All right, what is the equation for finding little r? Well, my little r is going to be equal to 1 over n minus 1 times the sum of from 1 to little n. I'm going across all my individuals and then dividing by the degrees of freedom. This looks a lot like an average or a standard deviation, right? Now, what's inside the next part of the equation? It has two parts. It has a part for the X variable and a part for the Y variable, and they're the same. I'm going to have my little X sub I minus my X bar, right? That looks like my deviation, but then I'm going to divide it by the standard deviation of my X variable. So x sub I minus x bar is going to be in the units of x. If I divide it by the standard deviation, which is also in the units of x, I will get a unitless quantity for this part of my equation. Same thing over here. Y sub I minus y bar divided by the standard deviation of y. Right now I multiply each of these two terms together. Right. So for each of my individuals, I'm going to calculate these two terms, multiply that together, and then I'm going to add that to the same thing calculated for my next pair of observations all the way down through. Right. So I'm going to start with my x sub 1 and my y sub 1. They're a pair, they go together. Those of you who are understanding this formula, you're seeing how tedious this is going to be. So I'm going to start writing out the terms of this equation. And I'm not going to write them all out because that just is very tedious. All right, so my little r is going to be equal to 1 over, I've got 12 minus 1. Now, instead of taking a sum sign here, I'm going to actually start writing out these terms. So I'm going to have my x sub 1, 14.4, subtract my x bar, 12, and divide my standard deviation of x, 6.5. First term for my x value for crab number 1. I'm going to get my y value for crab number 1. It's observation minus its y bar divided by the standard deviation of y. Right, so I'm going to first do the subtraction, then do the division. Same thing over here. Then I'll multiply those two quantities together. So notice that some of these terms are going to be negative values. Some are going to be positive values, depending on whether the individual observation is larger or smaller than the mean. But instead of squaring these terms like we do to find the standard deviation, we're multiplying these two terms together. So we can have negative values if one of these terms is negative and the other is positive. We'll have positive values if they both come out positive, or if they both come out negative. So that's how we build into the equation the fact that this value, little r, comes out to be negative if there is a negative slope in the data, and it comes out to be positive if there's a positive slope in the data, because those correspond to this relationship between each value of x and its mean, combined with the relationship between the value of y and its mean. All right, so that's my first term. I'm going to do that multiplication and division and multiplication, and then I'm going to add that to my next. I'm going to take crab number 2, 15.2 minus 12 divided by 6.5 times crab number 2's y value, 179 minus 196 over 106. I'm going to add my next term, which is for crab number 3, 11.3 minus 12 divided by 6.5. Right, I'm doing the same thing in each of these terms. I'm just swapping in my different values of x and y. Right, 11.3 goes with 100. 2.5 minus 12 divided by 6.5, quantity times 45 minus 196 divided by 106 plus, I'm going to do some dots here. We're getting tired of doing this, down to my last observation. All right, closing my brackets there. Remember, I have to do all these multiplications, add these up, and then not forget to divide by 11 at the end. All right, so if you do all those calculations, you'll get 2, right? And you should do this in your calculator and make sure you get the same answer. 0.863. So that's what my little r equals. So another thing that we're going to calculate, that is, we're going to find r squared. All right, so the relationship between r squared and little r is we're going to take little r and multiply it times little r. So r squared is literally square of a value of little r. And in this case, it equals 0.74. All right. So little r tells us the strength of the association. So this is pretty strong. This is pretty strong. R squared is a little more specific. All right. So this value of our r squared is going to tell us that we got 0.745. So 0.745 of variance in my y variable. All right, so my y variable is gill weight. And the crab gill weight is explained change in crab body weight. All right. So my r squared value, variance in whatever my y variable is explained by change in whatever my x variable is. This is a very specific summary of what is r squared telling you, right? About 75%. I know about 75% of why crab gills are how big they are if I just know how big the crab is. Right, so those two tasks that we might be asked to do using our correlation and regression data, we have two more to go. One is that we're going to do, so we have part 1, part 2, part 3. We're going to find the equation of the regression line for our data. Equation of any line or of a regression line is going to be y hat equals a plus b times x. The reason we have a y hat, you can just write y, but this hat tells us that this is an estimate or a model. All right, so in order to find the equation of the regression line, what do? Well, we just have to find a, the intercept, and b, the slope. Once we have found our means, our standard deviations, our little r, we can easily find the slope and the intercept because there are formulas for them. We first have to find slope. The equation for us to find the slope is little b equals little r times s of y over s sub x. All right, so look at this equation. We're multiplying the slope times little x. Then we're going to add it to a, and that's going to give us a y value. So the slope is actually converting from the units of x to the units of y. We can't add units of x together with units of y, so we have to actually convert our units of x into units of y. And so we do that by multiplying by standard deviation of y divided by standard deviation of x, because if we multiply an x times this, the units of the x are crossed out. The mathematical word for that is, they disappear magically, and we're left with a value that's in the units of y. All right, very, very easy to calculate. You just have to know this equation exists. All right, what does it equal for our particular example here? Little r, which we have over here, 0.863 times the standard deviation of y divided by the standard deviation of x. All right. We make that calculation. What do we get? We get 14.14. Right. The units of B are going to be the units of y divided by x. So this will be milligrams per gram. Right. Little r is unitless. R squared is unitless. All right, we found our slope. Now we have to find our intercept. We're going to define our regression line so that one of the points of our line is x bar, y bar. So in the way that we have decided we're going to make a regression line, it's going to go through the point x bar, y bar. All right, so that allows us to solve for the intercept because we're going to substitute y bar and x bar into our equation because we have this point. We have this point. And so if we do that, we're going to say y bar equals a plus b and x bar. Right now we want to solve for a. So we're going to subtract b times x bar from both sides. So we're going to get y bar minus b times x bar equals a. So this is an equation. I'll give you this equation, but that's where it comes from. We define the line as going through the point x bar, y bar. We find b, and then we can solve for a. All right, so I've got y bar 196 minus 14.14 times x bar 12, and that equals 25.5. All right, I have found B, I have found A. I am not done because I was asked to find the equation of the regression line. That means my answer, I'm going to write it out, substituting these values in. All right, so here's my answer for what is the equation of my regression line. And our last question we might be able to work, or we might be asked to solve, is to find a value of y given a value of x. And so for example, if x equals 22.7, what does my y equal? Right? What size of gill, what is my predicted gill weight for a crab with body weight 22.7 grams? All I have to do is substitute this x into my equation and calculate it. So that's going to equal 25.5 plus 14.14 times 22.7, pardon my paper. What? So that's going to give me 245 milligrams. All right. So these are the only types of calculations that I'm going to ask you to do. If you have every single data point. How do you know you're being asked to do this? Right. Find the correlation coefficient. In order to do that, you have to have every single value here. You're going to see a big data table with the listed X values and all the Y values that go along with them. If I haven't given you all the data, you can't calculate the little r. I have to give you the little r. It's possible that I could give you the r squared value. Right? How are you going to find the little r? Well, you're going to take the square root of it. All right, take the square root of it to find little r. There's a possible scenario that's a little tricky, and that is if we have a negative value for little r, when we square it, that negative goes away. So you'd have to see a graph of the data and know that it has a negative slope so that you would want to report a negative value for the little r if you found it from the r squared. Right. If I just give you the means and standard deviations, right, you can find the equation for the regression line, but I would have to give you little r unless I've given you this entire data table. Okay, so these are the things you might be asked to work out by hand. Now I'm going to go back to the set of data in Excel and show you how to do this using Excel. All right, here we are in Excel. We're going to find the average of our data set for the X by typing in equals average and putting in the cell address range. We're going to find the standard deviation by using the stdev.s function, putting in the data range. All right, now we can, because we're doing the exact same thing on the column that's just to the right, and the cells are arranged in exactly the same way, we can copy. I'm going to use Control-C and paste, Control-V, and it has pasted the formulas that has shifted over the cells they're taking the average of to my column D. Right, so in column C, it says average C3 to C14. If I copy and paste that formula to the cell to the right of it, it'll shift the formula so it says average D13 to D14. This can be quite handy. And I copied and pasted both the formulas for average and standard deviation. All right. We can ask Excel to find the correlation coefficient. We're going to do that by using Data Analysis Toolpack. Correlation is the function that we want to use. We're going to put in the input range here. That's not what I want. So I'm going to highlight the cells of the data, including both the X and the Y. It's going to assume that my data is grouped by columns. I have my X in one column, my Y in a second column. My output range, I have to tell it where I want it to put the results. F5 is fine for that for me. So when I click OK, it gives me a little data table. The correlation between column 1 and column 1 is 1. It's perfect. 14.4 is perfectly correlated with 14.4. Right, my correlation coefficient, my little r, it gives me in this table, right, 0.865. That's a little different than what we calculated by hand, and we're going to see that this is true, that this happens when we calculate by hand compared to when we calculate using Excel. Excel has used a gazillion decimal places past the decimal point, so when we round off the decimal places to make our calculation by hand, we are going to end up with rounding error. And rounding error can be fairly large in this calculation because there's so many terms and we're doing so many multiplications. All right, so we're going to do just a couple really small examples for you to calculate this by hand, but for the most part, we're going to use Excel to make these calculations because it's just going to do a better job than we're going to do by hand. All right. So we can find R squared by typing in equals this cell G7 times G7, right? 0.74, what do we get? 0.74, 8, right? Rounding error is going to give us a different than what we calculated by hand. But if we're going to be making a graph of our data, we can find out these values in a little easier way. So if we're going to make a graph of our data anyway, you can hold off on making those calculations. We're going to make a graph called a scatter plot. And to do so, we're going to highlight all of our data, both columns, and Excel is going to put the column that's on the left on the x-axis, and it's going to put the column on the right on the y-axis. You can swap them, but the easiest thing to do is simply copy and paste them. If you don't happen to have them with the x on the left and the y on the right, just copy and paste them so that they are. I'm going to go back to the home menu, to insert charts. I'm going to go to the scatter plot, and we want this first kind that just has dots on it. I'm going to delete the title. My dots are blue. I want them to be, why is it not letting me change the colors? Sure. I'll try right clicking. Okay. My plot area. I'm going to format the data series. All right, once I have asked it to format anything on the chart, it's going to give me this menu to the right-hand side. I'm going to go to the paint can for fill in line. I'm going to go to marker, because that's what these little guys are called. And I want to change from blue to black. I said, oh, that was the border of the markers. I want the fill of the markers to be black. There's so many options in Excel. No, really, I want the fill to be black. Oh, it only did one. I didn't have the whole series highlighted. That's aggravating. Fill, I want the fill to be black, I said, for the whole series. Thank you. Okay. So in case you were wondering, I do have my little aggravations with Excel as well. I make that a little smaller so that I can see the whole thing. All right, what else do I need on my graph? Hopefully you notice there's no axis titles. For whatever reason, Excel never seems to put them on. We need to go to add chart element, axis title, primary horizontal, that's my x-axis. Right, so body weight in grams. I also need a y-axis title, vertical, gill weight, milligrams, right? Be careful when you're making your axis titles. If you're capitalizing these words, always capitalize them. Make sure you put parentheses around the units and do it the same on both axes. All right, gill weight versus body weight. Okay, so this is my scatter plot. If I want to put a regression line on here, that is also an add chart element. All right, so if we go down here to trend line, we want to do linear, and it's going to put a line on there. I'm going to click on the line, and since I already have my formatting menu up, if I hadn't, I could do right click and go format trend line. And it would give me the same menu options over here. I don't like the fact that this is blue and it's dotted, so I'm going to go to line. I'm going to make it a solid line. And I'm going to make it black. Thank you. Somehow it's decided it's going to be dashed. I want it to be solid. And if I go to the trend line options, showing the little histogram icon or the graph icon, if I scroll down, this gives me the option to display my equation on my chart and also to display my R² value on my chart. Do you want to do that? There we go. All right, so it's going to plop them down in this little text box. Usually it lays them somewhere inconvenient, but you can just drag it and drop it somewhere else so that it's not laying right over your, laying over your dots. All right, so it gives me my R². And remember, I did that by clicking on the trend line. So I got format trend line. I went to the graph options. I scrolled down and I just clicked these check boxes: display equation on chart, display R² on chart. So I don't have to calculate my little R, because if I do this to make my graph and then find the R², it's going to calculate it for me, right? How do I find my little R? I take the square root of my R². This graph happens to have a positive slope, but if it had a negative slope, make sure and put that negative sign on your little R once you calculate it, right? And here it gives me my equation of my regression line, y equals 14.188 plus 24.654. That always gives a ton of digits for some reason. And we're kind of working with this weird unitless numbers. And so usually we actually use 3 or 4 decimal places when we're writing down our R² and our equation of our regression line. Equation of the regression line, you can, if you're writing it down on paper, then you could cut off a decimal place or 2. All right, so that is how we are going to make a scatterplot graph. And that is how we are going to find the equation of the regression line and the R² value using Excel to help us. Pretty easy stuff.